Okay, good morning, children. Here we are again. We'll be continuing with algebraic expressions only because last time I could do till number 4, right? So, number 4, the questions were identify like terms in each of the following, right? So, I had explained earlier also. So, today we'll continue with number 5, then we'll move on to the other exercises, addition and all. So, number 5 says identify polynomials from the given algebraic expressions. Okay. So, let me just write down. I'm not going to write the way it is there in the book. I'm going to write it the way I've done it in my own personal copy. Or x square minus 4 by 9 x square plus 4. Number 2. 2 by x plus 3 by x square minus 4x square plus 3x plus 2. Okay. Then we have number 3. Number 3 is 3a cube plus 4a square b plus 8b cube, and fourth one and the last one x square minus, this is a formula also. Right. So the question states identify polynomials from the given algebraic expressions. Okay. Answer is number 1 and number 2. Okay. They are polynomials. Number 1 and number, sorry, not 2, 3. Number 1 and number 3 are polynomials. Why? Okay. Now, if we go back to page number 152, not 152, 153, an expression containing a term of the form 1 upon x, comma 1 upon x square. Okay, I'm going to do the explanation part. Okay, 1 upon x, comma, that's what the book says, 1 upon x square, comma x upon y, comma x square upon y, etc. is not a polynomial. Why is it not a polynomial? See, this is not a polynomial, this is not a polynomial. Why? Because we were talking in algebra, I've talked about constants and variables. Okay, variables are the alphabets or a combination of alphabets and numerals, okay, or numericals, right? If it's only if the numerical or the number it's in this format, it's in a fraction format, it has to, the denominator has to be a number itself. That's why then only it can be called a algebraic expression or a polynomial as the question states, right? So in these cases, let's see, it's 2 upon x, 3 upon x. It cannot be. This, no, this is not an algebraic. This is an algebraic expression, but not these two. Similarly here also. So that is why number 1 and number 3 are polynomials. Okay, get this very clearly because right now we are just doing one sum, but later on in the higher classes you'll have to do more. Okay, now number 6, write down the degrees of the following polynomials. I'm going to do number 1 and you'll have to do, I'll give you the homework for this. Okay, so number 5 there's no homework with this, I just have to explain what a polynomial is, right? Now we'll move on to number 6. I'll do number 6, 1. Okay. Number 6, 1, the question is 4x squared minus x to the power 4. Okay. So I think in my previous video I talked about degree. No, I haven't talked about degree. I'll have to. Okay. So first let me talk about degree, then I'll come to this question. Okay. Now, page number 152. I have already done like terms, unlike terms. Now it says type of algebraic expressions. Okay. We have terms like monomial, binomial, trinomial, and all. Okay. What does it mean? Okay. Monomial expression. Let's do this. Okay. Now, a single expression, a simple algebraic expression is called a monomial. Mono. That's one. By, two, try, three. Okay. Mono. So one. If there's only one expression, it's called a monomial. For example, bx squared, xy, just etc. Just one expression is called a monomial. Binomial, as it says, 2. I'll use the example from the book only. 2b, I think it's plus 3c. Yeah, 3. 2b plus 3, comma, the not example given is 5b minus 7q. So can you see there are two terms because they're separated by a plus sign and a minus sign. So binomial, etc. You can figure out more for yourself. Okay. Trinomial, again, according to what's given in the book, I will do that. Trinomial is 3. Okay. So I think in the book it's given as 2a square minus 3ab plus 5b. Understood? So there are three expressions. So this is called a trinomial. You can see it's separated by the plus and minus. So 1, 2, 3. 3 expressions. Okay. So trinomial. So the fourth point says a compound expression on the polynomial is an algebraic expression of 2 or more. So see, now we come to the term called polynomial. Poly means what? Poly means many. So any algebraic expression which is more than 2 terms. Sometimes we have many terms, okay, like 5a plus 6c plus 2xy plus a square b plus 7 plus 26 abc. So how many terms are there? 1, 2, 3, 4, 5, 6. So if it's more than 2, it's called a polynomial. But till three expressions, we have a term called trinomial, right? So generally speaking, normally speaking, if it's more than 3, we'll call it polynomial. But actually, polynomial means more than 2 expressions. Okay, so that this is very important. Now, degree, polynomial degree. An algebraic expression of the form a plus bx plus cx squared plus dx cubed plus whatever, where a, b, c, and d are constants and x is a variable is called a polynomial. In x, the degree of polynomial is the greatest power of the variable. Okay, and now this it sounds, the words are very, they could have simply written numbers instead of alphabets. I'll just go to the example and I'll show you what it is. Okay, now look at example 1. So we are dealing with degree now. Degree of a polynomial. Okay, now look at that example 1. I think this is 6 minus 7x. Six minus 7x is a polynomial of x, polynomial in x of degree 1. There's only, see, we do not deal with the constants, we deal with the variables. There's only one. So the degree of this is 1. Okay, so you can see only one alphabet or a variable out there. Okay, let's go to number 2. This will make it a little bit clearer for you. I think see children, why am I doing examples from the book is so that you can refer and go through my video. It makes it clear. 7x squared plus 2x plus 5. Okay, 7x squared plus 2x plus 5. What does the book say? Is a polynomial in x of degree 2. Now look at this. Forget the number, the constant. Okay, look at the variables. X. This is x to the power 1. This is x to the power 2. Which is higher? Understood? It is this one. So the degree is 2. That's how we do it. Okay. Now the third one, 8x to the power 4 minus 2 by 3 x squared plus 4 by 5 x squared minus 8x minus 4 is a polynomial. Okay, let me do this. This is a long one. I think it will be much more clearer. Eight x to the power 4 minus 2 by 3 x squared plus 4 by 5 x squared minus 8x minus 4. Okay. They say, now look at this. Forget the numbers. Look at only the variables. Forget the constants. I don't mean numbers. Okay. Now 8x to the power 4. 2 by 3 x to the power 2. 4 by 5 x to the power 2. So this, the power of this x is 1. The power of this x is 2. This is 2. This is 4. Which is the greatest one? Obviously 4. So the degree becomes 4. Okay. So that's the way we. Okay. Now, note it says if the polynomial is in 2 or more variables, then sum of the power is the polynomial. That means the expression, algebraic expression polynomial is in 2 or more variables, then the sum of the powers of the variables in each term is taken and the greatest sum is the degree of the polynomial. Understood? That means in an expression there are more than 2 variables, alphabets, or a combination of alphabet and a number, and they have powers within themselves. Okay, so it says the sum of the powers of the variables in each term is taken and the greatest sum is the degree of the polynomial. Okay, so let's go to the examples. The first one, 3x squared minus xy plus 4y squared. Okay. Is a polynomial in x and y, the sum of the powers of the variables of each term is 2 respectively. Okay. It says it's 2, 2, 2 respectively. What do you mean by that? So the degree of polynomial is 2. So this is already 2. This is already 2. This is 1 and 1. 1 plus 1 will be 2. So all the variables, the power is 2 and it's not lesser than 2 or more than 2. So degree will be 2. Let's say, for example, if it was, okay, let's see the second. I will not give my own example. Let me go for the second one. I hope it's clear. 3x squared plus, this one is good, 4x squared y squared minus 6x cube plus 4xy is a polynomial in x and y. The sum of the powers of the variables in each term are 2, 4, 3 and 2 respectively. Hence, the degree of the polynomial is 4. What do you mean by this? You don't see any 4 anywhere. You see 2s, 2s, 3s and this is 2. Okay, so what do you mean is this is 2. The degree of this is 2 because of this. Okay, this will be 2 plus 2, 4. 2 plus 2, 4. This is already 3 and this will be 1 plus 1, 2. That's why I think they've given it as 2, 4, 3 and 2. So which is the highest? This. So the degree will be 4. Understood? So this makes it much more clearer. Okay. So now let's move on to the degree sums. So as I was saying, number 6. Question is given as 4x squared minus x to the power 4. Okay, as you can see, highest degree of the variable is 4. I mean the highest number is 4, so the degree will be 4. Okay, so your homework is number 2, number 3, okay, number 4 and number 5. This whole thing is going to repeat it again. Exercise 9A, page number 153. Okay, children. So with this we come to the end of exercise 9A. How many minutes?